You are looking at one of the driest regions on Earth, a place where people plan their days around heat, a place where water is not a resource, it is a mission. Yet in this same region, small villages are getting water from technology that does not look like technology. It looks like a giant fishing net standing in the desert. It looks simple, but it can capture water straight from the air. Germans helped make this system possible. The goal was clear: bring water to people who live in places where rain rarely falls. Today, you will see how this mesh works, and by the end, you will understand how millions of liters can come from nothing but wind, humidity, and material science. Let's start with Morocco. One of Morocco's specialties is fog. Surprisingly, with mesh of the proper type and placed and angled correctly, water can be harvested. Droplets hit the mesh, they stick, they merge, they become heavier, they drip down into a gutter. The gutter sends the water into a tank, and that's the entire idea. The first large installation of this system is in the Anti-Atlas Mountains. Villages like Sidi Ifni and Ait Bamrane rely on it. These areas face long dry seasons. Women used to walk several hours to fetch water. Now they only walk to the tap near their homes. The system is known as CloudFisher. It was designed by a German industrial designer named Peter Trautwein. His team worked with Moroccan groups and global water organizations. The question they wanted to answer was simple: can a passive system harvest water without electricity and without maintenance headaches? They found a way. You can think of the mesh as the central component, but the mesh alone is not enough. Fog collectors have existed before, but they failed in strong winds. Meshes would tear, frames would collapse, nets would clog. Trautwein tested dozens of materials in wind tunnels. He wanted something that would handle mountain winds that can reach 120 kilometers per hour. The mesh also had to keep collecting water even when the wind changed direction. Many materials did not work. Others worked, but broke after a few months. The final version used a tough polymer. The structure became flexible instead of rigid. Instead of fighting the wind, it moved with it, which increased its lifespan and reduced repair costs. The mesh is manufactured from high-density polyethylene, and the droplets that are suspended in the air are attracted to the surface textures created in the fiber construction. If the openings are too small, airflow drops. If they are too large, droplets pass through. CloudFisher uses a two-layer system. The first layer catches the droplets, the second layer reduces the pressure on the first layer and slows the wind. This helps droplets stick long enough to merge and fall. Each mesh panel connects to a frame made of steel. The system stands on concrete bases. The water flows into pipes that lead to storage tanks. From there, it flows into homes. All of this happens without a pump. On days when the fog is heavy, a single square meter of mesh can gather up to 12 liters of water. When you scale that up across 100 square meters, the output becomes large. Some installations generate more than 20,000 liters per day. Over time, that adds up to millions of liters, all from fog. This has changed daily life in these Moroccan villages. Before the system, women spent almost half a day carrying water from distant wells. The water was not always clean. Now they have access to cleaner water right in their homes. Children have more time for school. Some use it for small-scale irrigation and some for cooking. The system turned fog into a community resource. The surprising part comes in summer. Summer should be the worst time for fog collection. Heat removes moisture. Yet in coastal mountain zones, summer still brings fog. There is less of it, but the mesh continues working. The conclusion, however, is that fog does not depend on any rain. Fog is formed when the humid air from the water is met with the cooler air of the mountain. That means even during summer, when the ground is arid, air still carries moisture, which means the temperature difference can still create fog. As long as airflow continues, fog collectors continue collecting. The system only struggles during heat waves with inland winds. During those days, humidity drops. The mesh collects less water, but even then, the villagers rely on stored water. Water tanks are built for several days with low fog because they are large enough to support a scarcity of water in the peak of summer. So how does it work? It begins with the fog. As the wind blows, droplets hit the mesh. The mesh has a hydrophilic surface. This means water spreads instead of bouncing off. Droplets stick, merge, and move downward along the fibers. At the bottom of the mesh is a trough. The trough captures the water and sends it through a pipe. The pipe leads to a main collection tank. The tank holds thousands of liters. Villagers collect water from taps connected to the tank. There are no engines in this process, no filters, no solar panels, no motors. The design depends on humidity and wind. That is why maintenance is low. Workers check the mesh for damage, they clean debris, they check the frame. That is the extent of the upkeep. The idea looks simple, but the science behind it came from decades of understanding fog physics. Scientists studied how droplets collide with surfaces. They studied how fiber thickness changes water capture. They studied how wind patterns influence fog density. CloudFisher used all of this research. The question you may now have is whether this works only in Morocco. The answer is no. Fog collectors are successful in multiple regions. In Chile, fog collectors provide water to communities near the Atacama Desert, where Chilean researchers built large mesh systems on ridges in the coastal mountains where they rely on fog banks. Some produce 30,000 liters per day. The Atrapaniebles system uses large triangular structures. The frames capture fog passing over ridges. Chilean scientists improved the mesh by adding textured surfaces. These surfaces increase droplet capture. Meanwhile, in Peru, fog collectors support urban gardens through the Lomas de Lima project that uses fog nets to support reforestation. As water drips from the nets, plants grow below. Over time, this creates a microclimate. The plants also help retain moisture, and this increases fog formation. It becomes a cycle. And back on the African continent, fog harvesting provides drinking water in remote villages in Eritrea where the climate is harsh. In South Africa, similar systems are used for wildlife reserves. Rangers collect fog water for animals and plants in zones with irregular rain patterns. Even Europe is not an exception. In the Canary Islands, fog nets capture water from trade winds. This helps restore native forests. All of these projects use the same principle: capture droplets from the air, convert them into usable water. When you compare these systems, you notice one pattern. Success depends on three conditions: humidity, wind, elevation. If all three exist, fog harvesting works. In Morocco, these conditions align perfectly. The German contribution to the Moroccan project was not only about design, it was about making the system durable enough to last years instead of months. Earlier fog nets tore easily. CloudFisher used a tensioning system that kept the mesh stable. The frames were anchored to resist wind loads. The mesh was engineered to avoid clogging from sand and dust. These details matter because remote villages cannot afford constant repairs. Let's break down the material further. The mesh fibers are just the right thickness to support the weight of any water droplets that they may collect, but are also thin enough to be able to catch the smaller droplets. The material used in CloudFisher lasts several years longer than earlier meshes. The frame uses tension ropes. These ropes provide flexibility. When the wind blows hard, the frame moves slightly. This prevents fractures. The mesh also uses a hook system that lets workers replace sections quickly. That means you do not need full tools, and this makes maintenance faster. The collectors also have a unique gutter shape. Instead of a straight pipe, the gutter curves. This forces water to flow smoothly even when the wind blows from different directions. The design prevents overflow during peak fog hours. Fog collectors are not meant to replace traditional water systems. They are meant to fill gaps. They help regions where drilling wells is difficult. They help places where rainfall is unpredictable. They help communities that do not have money for desalination plants. You might ask how effective fog collection is across a full year. In Morocco, annual output depends on elevation and proximity to the ocean. Fog seasons last from late fall to early spring. This is when collectors perform best. Summer still produces water, but not as much. Over the year, a typical installation generates enough water to supply hundreds of people. Fog collection also supports agriculture. Small farms use collected water for drip irrigation. This saves crops during dry spells. CloudFisher installations focus on sustainability, and because there is no electricity, the carbon footprint is low. The system also uses local labor for assembly, allowing communities to gain technical experience. And because the water comes from nature, the cost per liter stays low. You might wonder why Germany plays a major role in this field. German engineers are heavily involved in material science. They design polymers, fabrics, and structural systems. CloudFisher needed a precise balance between strength and flexibility. Germany's engineering background made this possible. The system itself is inexpensive compared to drilling wells or constructing pipelines. It is also safer for communities that lack infrastructure. Wells can become contaminated. Fog water bypasses the soil. This reduces contamination risks. The main concern is airborne pollution, but in rural mountains, the air quality is high. The biggest challenge for fog collectors is climate change. As temperatures rise, humidity patterns shift. Some regions may lose fog, others may gain it. Researchers monitor long-term changes to make sure installations remain viable. CloudFisher is part of a broader idea known as atmospheric water harvesting. This field includes fog nets, dew collectors, and condensation machines. Fog nets are the simplest form. They require no power. They work with nature instead of against it. Condensation machines can extract water from air using cooling coils. They produce more water, but need electricity. This limits their use in remote areas. And the last component, the dew collectors, rely on surfaces that cool at night when water condenses on the surface. Although dew systems produce less water than fog nets, they work in places without fog. Fog nets are ideal for coastal mountains. That is why Morocco's geography is a perfect match. Now let's look at the human impact. In Ait Bamrane, women used to walk 4 hours per day for water. After the fog collectors were installed, walking time dropped to minutes. School attendance increased, health improved, waterborne illnesses decreased. Families saved money because they no longer needed trucked water. The impact is measurable. Villagers also participate in managing the system. This builds ownership. People clean the nets, they check the ropes, they maintain the tanks. This ensures the project continues long after installation teams leave. Water from fog also tastes different. It is soft water. It has low mineral content. This makes it ideal for household use. Some villagers say tea tastes better with fog water. This type of technology does not transform entire nations, but it transforms communities. When a village receives water, everything changes. Children can study, women can work, farmers can grow crops, people can wash their clothes regularly. Health conditions improve in the long run. But Germany's involvement continues. Engineers refine the mesh each year. They experiment with new polymers, they test new shapes, they study fog behavior. The goal is to maximize every droplet. The question now is whether fog harvesting can scale up. Can it serve thousands? Millions? Probably not. For now, fog harvesting works best in small to medium communities. But for those communities, it is a lifeline. The Moroccan government has also shown interest in expanding the system. They see it as a low-cost way to support rural development. International groups also support it. Many see fog harvesting as a climate adaptation tool. It is also an educational tool. Students learn about material science. They learn about climate. They learn about sustainability. Fog collectors become a classroom. Let's now compare the cost. A full fog harvesting installation with dozens of mesh panels can cost tens of thousands of dollars. That includes frames, pipes, tanks, and labor. But once installed, the cost of producing water is close to zero. Only occasional repairs are required. Compared to desalination, fog harvesting is far cheaper. Compared to trucking water, it is far cheaper. Compared to building wells, it avoids geological risks. Fog harvesting also supports ecosystems. In some regions, collectors provide water for reforestation. Trees then trap more moisture. This creates a positive cycle. The strength of the German system is reliability. Fog may come and go, but the mesh continues working year after year. The early prototypes lasted only a few months. CloudFisher lasts more than 10 years with proper maintenance. That durability matters in remote areas. When a system breaks, it may take weeks to get replacement parts. The flexibility and strength of CloudFisher solved this problem. Now you might wonder what the future holds. Scientists are exploring hybrid systems, mesh panels combined with nano coatings, meshes shaped in three-dimensional patterns to increase droplet collision, surfaces inspired by desert beetles, fog tunnels that channel fog into collectors. All of these ideas show that fog harvesting is still evolving. These upgrades are not science fiction. They are under development in labs. You will see many of them appear in the next decade. One of the biggest areas of research is self-cleaning mesh. The current mesh works well, but dust builds up, reducing water capture. That means sandstorms, quite common in the Sahara, can reduce performance. Workers clean the nets manually. That takes time. That requires climbing the frames. It also interrupts water collection. Engineers want a surface that cleans itself, and self-cleaning polymers could solve this issue. The idea behind self-cleaning mesh is simple. Make water droplets and remove dust. You see the same idea in some plants. Researchers study how certain leaves shed dust when it rains. They copy the micropatterns. These patterns make water slide across the surface and carry away dirt. When applied to fog collectors, the mesh stays clean longer. This increases daily output, and it also reduces maintenance. There are different approaches to self-cleaning mesh. The first approach uses hydrophobic coatings. These coatings push water away. Droplets do not spread. They roll off. As they roll, they pick up dust. This clears the mesh. Another option is to use hydrophilic coatings. These coatings do the opposite. They pull water across the surface. Instead of rolling, droplets spread and wash dust away. This creates a thin sheet of water that cleans the fibers. A third approach uses mixed surfaces. Some parts attract water, some parts repel it. This forces droplets to move in controlled paths. As droplets travel, they clean the mesh. These techniques extend lifespan. They also address one of the biggest challenges in desert environments: dust. A self-cleaning mesh removes dust without any tools, and that means villagers spend less time repairing and more time collecting water. There is also interest in robotic maintenance. Fog collectors cover large areas. Workers check every panel. That takes hours. Engineers want small robots that move along the frames and inspect the mesh. These robots would detect broken fibers. They would measure tension. They would scan for sand buildup. They would identify sections that need replacement. Some robot concepts use tracks. They move up and down the frames like climbers. Others use magnetic wheels. They attach to steel frames. A few concepts use drones. The drones scan the mesh using cameras and sensors. They look for tears. They check alignment. They send reports to the team. One advanced concept is large fog fences. These are massive structures placed in strategic locations to harvest tens of thousands of liters per day. Countries with coastal mountains are testing this, but the heart of fog harvesting remains simple. Capture droplets, let gravity do the work, deliver water. The Moroccan installation is a reference point. It shows that fog harvesting can operate at scale. It shows that technology does not need to be complex. It shows that engineering can adapt to local conditions. The German team studied every challenge: strong winds, sand, sunlight, maintenance limitations. They solved each problem with design adjustments. The success of fog nets also depends on community training. Villagers learn to tighten ropes. They learn to clean mesh surfaces. They learn to check tanks. This keeps the system running. Now think about the Sahara Desert. You see dunes, you see heat, but along certain edges, moisture exists. Fog moves inland. It reaches mountains. Fog nets capture that moisture. That creates the surprising outcome you see today: millions of liters collected in a desert environment. Some ask why fog nets are not used everywhere in the Sahara. The reason is simple. Fog must be present. The Sahara interior does not have fog, but the coastal edges do. That is where fog collectors work. Morocco's geography is special. The Atlantic Ocean brings moist winds. The Anti-Atlas Mountains cool those winds. Fog forms. CloudFisher captures it. Germany's engineering turns that fog into water. This is why the system is called unbelievable technology, not because it is complicated, but because it solves a water crisis using a lightweight mesh. And it does it without electricity, without pumps, without chemicals, without large infrastructure. When you look at a fog net, you do not think it can produce thousands of liters, but it does. And it keeps doing it over many years. And globally, each project shows the same pattern. The system supports people who live in difficult environments. However, fog harvesting is not a replacement for national water infrastructure. It is a complementary tool. It fills gaps. It supports resilience. It protects rural communities from water scarcity. The Moroccan-German system is considered one of the most effective because it solved durability issues. Many fog nets failed in strong winds. CloudFisher continues working. The system is now studied globally. Countries request training, engineers visit installations, universities conduct studies. The concept is spreading. Morocco plans to install more sites. Some will serve larger villages, others will support agriculture. There's also interest in combining fog nets with solar desalination. Fog water could supplement desalinated water to reduce pressure on plants. As climate change reshapes rainfall patterns, fog harvesting will become more relevant. Some regions will lose rain but keep fog. Others will gain fog due to temperature shifts. Fog collectors can adapt quickly. You do not need large engineering firms. You need mesh, frames, and local labor. Fog harvesting also supports disaster resilience. When drought conditions intensify, fog nets provide a steady water source. They do not depend on electricity or fuel. They continue working during crises. If you ever see a fog net standing on a mountain, remember what it represents. It represents innovation driven by necessity. It represents communities gaining control over their own resources. It represents the power of simple technologies to change daily life. Fog harvesting will not end water scarcity, but it will help thousands of people live with dignity in harsh climates. That is the story behind the technology. That is how millions of liters appear in one of the driest places on Earth. And that is how a mesh invented with German engineering supports families across Morocco.